Okay, our lesson today will be equations for a plane. With equations for a plane, we'll see the vector and parametric equations of a plane. So in order to have a plane, in order to have equations of a plane, we have conditions here. This is representation of a plane, like a pie. So in order to have equation of plane, we need, what do we need? We need three non-collinear points. Three non-collinear points. Non-collinear points means they are not on the same line. These are non-collinear points. They are not on the same line. Or we need two non-parallel direction vectors. Non-parallel means they are not multiples of each other. So non-parallel, then there should not be multiples of each other. So the vector, so since we have two, I can say the vector equation of a plane will be always x, y, z. Then we have always a point, starting point, x, y, o, z, o, plus s, which is a1, b1, c1, and then plus t, a2, b2, and c2. So s and t are parameters. We must have two parameters. And a1, this is direction vector 1, is a1, b1, c1. Direction vector 2 will be a2, b2, and c2. So we have two direction vectors. So the same way we can write the parametric equations of a plane. Parametric equations will be x equals xo plus sa1 plus ta2, and then y will be yo plus sb1 plus tb2, and z equal to zo plus sc1 plus tc2. These are the parametric equations. We have no symmetrical equations for a plane. No symmetrical equations for a plane. So we don't have symmetrical equations. Okay, so let's see an example of this too. Write vector equations of a plane which contains the points A 2, 5, 1, B -1, 2, 4, and C 3, -1, 5. It contains 3 points because we need 3 points in order to write an equation of a plane. Now from 3 points we have to find direction vectors. So we find one direction vector is AB, which means coordinates of B minus coordinates of A. B minus A, which means -1 minus 2 is -3, 2 minus 5 is -3, 4 minus 1 is 1, 4 minus 1 is 3. This is the first direction vector, or we can write it in simple form because I can divide all by -3, so it can be negative, or it can be 1, 1, -1. I can take this or that one, doesn't matter, because they are parallel. These two are parallel. Direction vector 2 is AC. AC will be direct coordinates of C minus coordinates of A. So 3 minus 2 is 1. Negative 1 minus 5 is negative 6. 5 minus 1 is 4. So since I have two direction vectors now, I can find, I'm writing the vector equation. Therefore I have two direction vectors. So vector equation will be, I take a point. Which point do I take? I take any one of the 3 points. It doesn't matter which one we take. X, Y, Z equal to 1.251 plus S, the first direction vector, which is negative 3, negative 3, 3, or I can take 1, 1, negative 1, it doesn't matter. T, 1 minus 6, 4. This is a vector equation. Okay, the second one, B. Find a normal to the plane x equal to 2 minus 4t plus s, y equals negative 3 plus 2s, z equal to t minus 4s. So we have parametric equations, therefore I have to find the two direction vectors. D1, the first direction vector will be coefficients of t, which are negative 4, 0, 1. Direction vector 2 will be 1, 2, negative 4. The coefficients of s are 1, 2, negative 4. The coefficients of t are negative 4, 0, because there's no t here, and 1. So now I need the normal for this one. Normal means perpendicular to both of them. Therefore, in 3 dimensions, normal is perpendicular to the other two vectors. So the normal will be minus 4, 0, 1, cross. 1, 2, minus 4. I do the cross product and I will get 2, 15, and 8. So using cross product, we got 2, 15, 8. Okay, so that's it. This is 2 examples for this one here.